Hi everyone and welcome back to Matthew Wister. Today we're going to be covering another chemistry topic, specifically mole calculations equations. Meaning we're going to figure out how we can convert from grams to moles and moles to grams, vice versa, using an equation and formulas. To start off, the main thing that we want to point out is that 1 mole is equal to GFM, or molar mass, or gram molecular mass. All of these terms mean the same exact thing and they all equal 1 mole according to the mathematical relationships part of your chemistry reference table. By knowing that 1 mole is equal to the GFM, we'll be able to create conversion factors. To start off, we want to figure out how we can convert from grams to moles using dimensional analysis. Part of this method starts with knowing the given mass in grams multiplied by 1 mole over the GFM. This is what I was referring to about our conversion factor, because this represents the same thing here, how 1 mole is equal to the GFM. For 1 mole, there is the GFM. Our second method is somewhat similar, except here we figure out the number of moles by dividing the given mass in grams divided by the grand formula mass, which is also in grams. The reason why it's important to have it in grams is because that way we'll be able to eliminate the grams and then be left with just the moles, which is exactly what we're looking for. So to practice, here we have a question that asks how many moles are in 29 grams of KF. KF contains potassium and fluorine. So to start off, it's asking how many moles are in 29 grams of KF. So they're giving us the grams. That is our given mass. And the moles is what we're looking for. And KF is the compound that we have to find the GFM of. So we can first use method 1, which is the dimensional analysis, by inputting our values. So our given mass is 29 grams, right? Multiplied by 1 mole over the GFM. We need to find the GFM, so if you haven't watched the previous video and don't know how to solve for GFM, I recommend you watch that video. So, we have 1K, 1 potassium, and its average atomic mass is 39.10. And fluorine, there's only 1 fluorine, and it has an average atomic mass of 19. Now we have to add these together. When we add these together, we get 58.1 grams, and that's our GFM. Now what we notice is that we have grams here and grams here, meaning they can cancel each other out. So we can cross out the grams here and the grams here. And now we're just left with multiplying. So we do 29 times the 1 mole divided by 58.1. So it'd be 29 over 58.1, which would give you around 0.5 moles. Now we can check our work through our other method. So in order to find the number of moles, we need to divide the given mass over the GFM. So once again, our given mass was 29 grams and our GFM was 58.1 grams. So we can cross out the grams on both sides because they cancel each other out, and now we have the same exact format as the first method when we're doing 29 over 58.1. So we would have around 0.5 or 0.5 moles of potassium fluoride. Now let's figure out how we can convert moles to grams. The method we're going to use is we're going to multiply the number of moles by the GFM in grams over 1 mole. The reason why this would work is because the moles would cancel each other out and we would be left with the grams. So let's do a practice problem. It says, if a chemistry experiment allows you to use 0.25 moles of aluminum chromate, how many grams must you measure out on the balance? The important information that we have here is that it says 0.25 moles of aluminum chromate, and here is the compound, and it's asking how many grams must you measure. So in this question, we're going to be converting moles to grams. So how many moles do we have? According to this problem, we have 0.25 moles. To multiply it to the GFM, which we're about to find, over 1 mole. So if we do over here, I'll do it on this side. We have Al2CrO4 and 3. So we have aluminum. How many do we have? We have 2. We have chromium, and we have 3 because the subscript of 3 is distributed. And then we have oxygen, and we have 12 because the 3 is distributed and multiplied to the 4. So now we figure out what the average atomic mass is. So aluminum's average atomic mass is 26.98. For chromium, it's 52. And for oxygen, it's 16. So we would get 53.96 for aluminum. We would get 156 for chromium. And we would get 192 for oxygen. Now we add these all together, and we will get 401.96 grams. So now we write that up here, 401.96 grams. And now we can do the dimensional analysis. So we can cross out the moles, and now we just multiply. We do 0.25 times 401.96, and we would get 100.49 grams. So your final answer would be 100.49 grams of aluminum chromate. Anyways, I hope this is helpful. In the next video, I'll be covering how to convert from moles to liters and liters to moles.